Hi guys, welcome to Beginner-Techies. In this video, I'm going to discuss about find peak element problem. This is most frequently asked question in coding interviews. So let us first understand the problem statement, then we will discuss about the solution approaches. So here a peak element is an element that is strictly greater than its neighbors. Okay. So the peak element should be greater than their neighbor elements, right? Given a zero index integer array nums, find a peak element and return its indexes. So we have to return the indexes of peak element. If there are multiple peaks, then we have to return the any of the peaks index. Okay. We need to consider these points as well. You may imagine that num of -1, num of n is equal to infinite. In other words, an element is always considered to be strictly greater than a neighbors that is outside the array. You must write an algorithm that runs in O of log n time. So we have to strictly go with this solution. We should not think about the brute force. We should not think about the O of n solution. We have to go with O of log n solution. Let us understand these examples first. Okay, so here array is given 1 2 3 1. So the peak element is, let's suppose 2. 2 is greater than 1. 2 is greater than 3. No, 2 is less than 3. So 2 will not be a peak. Now move ahead. So 2 is less than 3. 1 is less than 3. So 3 will be the peak element. Okay, so we have to return the index of 3, means 0 1 2. So 3 is at 2th index. Okay, next example is 1 2 1 3 5 6 4. Here if you see, 1 is less than 2, 1 is less than 2. Okay, 2 1 3. 2 is greater than 1, 1 is less than 3. 1 3 5, again 3 5 6, 5 6 4. So here if we see 5 6 4, 5 6 4. So here 6 will be the peak element because 6 is greater than 5, 6 is greater than 4. So we have to return the index of 6. So index of 6 is 5. Let's see these constants here. Num of I not is equal to num of I plus 1 for all valid I. Okay, right. So if we are talking about the O of log n solution, then let us understand this input nature first. So we can see the input nature is in increasing and decreasing order. At some point of time it is like sorting in ascending order. In some point of time it is sorted in descending order. So there is increasing and decreasing kind of inputs we have. So if you're talking about O of log n solution, then we can think about the binary search algorithm, right? But binary search algorithm is it's completely applicable for the sorted data set only, right? So here we have sorted, but not the complete sorted. It's increasing and decreasing order, right? So we have to build our logic based on that. If you have understanding of binary search algorithm, if you know the implementation of binary search algorithm, then we just need to do few changes in the code itself. In the binary search implementation code, there is a slight variation. Okay, so if we do the slight variation in the binary search implementation logic, we will get the result for peak. Okay, so if you don't have understanding of binary search, then I would highly recommend you to go with binary search algorithm first and understood the binary search implementation. In the last video I have discussed about the binary search implementation as well. I will share the link into the description box. So let me draw this example into the here. Okay, let's suppose we have an array. Okay, 1 2 3 5 4. We have this array. We have to find out the peak element. Okay, right? Peak element. Solution should be O of log n. So we have to decide it for binary search algorithm, right? Binary search algorithm. So in binary search algorithm, you first need to get the middle element, right? Middle element with the help of this formula, right? So if we check the middle element from this array, so if L is equal to 0, initially I am considering a binary search implementation. Okay, so L is equal to 0, R is equal to length of -1, so 3 to 5. So here the length is 5. 0, 5 minus 0 by 2, so 2 will be the middle element. So 0 1 2 3 4. Okay, so 2, so A of mid will be 3, right? A of mid will be 3. A of mid will be 3. So we have to check the peak element. So we will check peak element surrounding of this mid. We will check the left. We will check the right. Okay. If it is greater than both of left and right, then we will return the index, right? Return index. If it is like, if this is less than left, right? So if this mid element is what? If it is less than A of mid -1, in this case we have to update the R value with what? R value with mid -1. If A of mid less than A of mid +1, in this case we will check the right part, right? So we have to update the L. Okay, so this will be updated with mid +1. Check the first half of the array. In this case, second half of the array, right? So this is our core logic. This is completely a what? Binary search algorithm logic, right? So but here like if you're considering peak element, then of course this L and R value will be like start from 1. L will be start from 1, and this should be start from A of length -2, so that we can compare the peak with their neighbors. We can compare the mid elements with their neighbors, right? Otherwise we will get array index of bound exception. Okay, array index of bound exception, right? So let us implement this logic into the Leetcode, right here. So first we need to define the L value, and R is equal to nums dot length -2, right? So in the binary search algorithm, what we do exactly? So this L should be less equal to r. So we have to iterate till r. We don't know, like this will be updated based on the data we get it. Okay, right. So we need to get the mid element, and mid element should be calculated with what? L plus r minus L by 2, right? Right. If nums of mid greater than what? Their neighbor, mid minus 1, and nums of mid and nums of mid greater than nums of their neighbor, right? Mid plus 1. So in this case, okay, let me write. So in this case we can simply return the mid. This is what we need. But else if nums of mid less is equal to what? Nums of mid less than nums of mid plus 1. If nums of mid plus 1 is greater than nums of mid, so we will update this L value with mid plus 1. So we'll check the second half of the array. Else if nums of mid greater than nums of plus 1. Okay, so r will be updated with mid of minus 1. So we will check in the first half of the array, right? So if we see this implementation, this is like just a clone of binary search implementation, right? We just did the change, like there is a slight variation in the logic only. So we have changed this logic, right? So let me run this solution. Okay, why? Okay, sorry, here it is. Here I missed that. Let me run again. Okay, so here it should return as per the problem statement, should return minus 1. Okay, fine. So these two cases are passed. Let me submit it. Probably it will be break wrong answer, right? So we have to consider the edge cases as well. If it is 1, so then we have to return 0, right? If nums dot length is equal to 1, so we have to return what? 0, right? Let's submit again. Again we got the wrong answer. Why? In this case, so if we consider this case, 2 is the peak element, right? So we have to add this logic as well. Nums of 0 greater than nums of 1, return 0, right? So in the problem statement, if we have multiple peaks, we can return one of them. We can return the indexes of one of them, right? So let's submit this. Right now 45 test cases are passed. Out of 65, 20 is failed. Let me submit again. Okay, right, so again it is failed, but yeah, 56 test cases are passed, 65 out of 65, so total 9 test cases are getting failed. So what are the expected scenario? 1 2. Okay, so we have to add one more condition over here, and nums. Okay, sorry, this should be or condition, and here nums of nums dot length greater than nums of length minus 2. If that is the condition, then we have to return the minus 1, right? Let me submit again. I guess it should work. Yeah, fine. Right, so right, this is successfully submitted and we got the result in 0 ms, right? Right, so this is one example of binary search algorithm, right? In the last video I had discussed the binary search algorithm, so I thought we should pick up few problems based on the binary search algorithm. In next couple of videos I will pick some more problems based on the binary search algorithm, so that we can easily identify like of what problem exactly we need to apply the binary search. So this way we can easily solve the problem in a very optimized way and we get the solution. Thank you for watching. Bye bye.